they started the revolution around 2008, 2000, when they started putting out like, more third-party applications. So this is your entire picture. Well, the other thing that happens is for the mobile course, you have to say, a lot of people, by the way, how many people here are Java developers for Android? Nobody. Okay. iOS developers for mobile? Yeah, I mean, developers meaning you could be an artist or designer or whatever. You've worked on a game which is for iOS, right? So basically, as you can see, Android, this is basically the stack for OS. What this is Android has a Linux kernel, above which it has got a virtual machine where it has taken Java's virtual machine and it has modified it, called it Dalvik, which is where your apps run. So when you talk about an Android app, you're actually running inside a virtual machine. And everybody knows that basically when you develop a Java app, you can run it anywhere. So when you say that, hey, I have a Java app, it means that it could run on any device. Why? Because you have a virtual machine for that device, right? Not as true. So basically, let's look at this one. BlackBerry has also got a JVM, and Symbian can run a JVM. This is Nokia 900. It can run its own JVM. The point I'm trying to make is that JVMs or virtual machines, they enable you to run apps, but the underlying hardware underneath it may not support that. So for example, if you've got a Samsung phone which has got tilt features and other things, and HTC, a basic version, doesn't have it, your app may run very well on Samsung. The same code may not run on your HTC. So the whole principle of write once and run everywhere doesn't work great. Why? Because your underlying hardware is not the same everywhere. That is the problem that is there for phones. We don't have a standard hardware. Every provider is providing his own specific hardware where you can make a Java app, but it doesn't give you that much flexibility. And and of course, run everywhere doesn't work for everybody. Why? Because Google's JVM may not support the standard JVM and may not support what Symbian has as their own JVM. So essentially, when you write a Java app and you've got a piece of code, it may work very differently on different platforms, right? So what does this tell us? This tells us that like putting up a JVM on top of a kernel may be a good strategy to sort of like bring your phones into the smartphone industry, but it takes a little bit more than actually just putting a JVM on top of something. You need to really develop your platform for your strategy to be a smartphone, which is what I believe Apple has done. What they have done is they've taken macOS, they've customized it for iPhone completely. It is an iOS, that's what they call it. They call it an iOS. They don't have a JVM on top of it. They force you to develop in Objective-C. Why do they do it? Because that way they can control what you're developing and how you're developing rather than Java, right? Where you can say, oh yeah, my app is supposed Java, and then they say, no, we don't support this feature on what you have written on for that phone. That would break everything. So that's why they said, well, we'll just do Objective-C, and you're going to have to learn Objective-C and go and develop games on it. Well, they've done very well, and that has worked out very well for them. So that's what I was trying to say, is that iPhone is coupled very tightly to its iOS, its OS, and how it develops and it provides you access to all its features. So there's one API, one programming language, one platform. So you write game for one, it works for all the iPhone or iOS variants they have. Be it the pod, be it the phone, or be it the iPad. And that's what makes it cool. Yeah? Well, let's look at Android's architecture a little bit. I'll not spend much time on this one. Android, really smart. They have a very mature platform. They've got their basic kernel. They've got their Java virtual machine running here, and they give you access through to their basic layer through this core layer, and they've got a complete framework defined for that. This is your application development kit, which Android calls this thing. By the way, this is available through developer.android.com, I think. So just nothing fancy that I have done out here. My point here is that basically this architecture, they are not only allowing you to develop applications here in the Java layer, but they're also allowing you application development through C into this layer. So now you're writing Java apps, or you could write Java apps, or you could actually write native apps, which is through C and C++, which further complicates how you write games, right? Most of you guys may, well, some of you guys may be using this route, some of you guys may be using this route. It's up to you how you go about it. This is a non-standard way of putting out your platform. And by the way, this is Android structure. And I'll introduce you to how OEMs treat it, which is like, hey, how is HTC treating an Android? How is, say, Samsung treating an Android? We'll talk about that later, but let's just understand that this is there. Whereas for iPhones, you've got one stack. You've got a pretty simple system of how they go about it. You've got an API call which just goes through its drivers, reaches the hardware, and basically any tilt or any touch you do just goes up one particular structure. This is its standard thing. There is nothing other than this. They only want you to work in this layer so that they can control the rest of it. Anything they change below this stays always the same, right? So whatever games you write above this will always be the same. And they can keep changing these out from underneath you, and you won't even know it. Which is why Apple platform is a much more stable platform for development, according to me, as compared to an Android platform. And that's the core part that we have to look at. When we develop games, we have to look at the stability of a platform, because a game doesn't get developed in 7 days. You really have to focus on what that game is and invest your money and invest your time. And what happens is, over a period of time, you take what you have developed and want to keep going forward with this, right? Now, if your platform underneath is changing and your API is changing all the time, you have to keep developing it that many more number of times, whereas that doesn't happen for Apple. It's one standard API that they always give you for, so your calls are always same, but you can keep shifting out for iPad, iPod, or whatever, you know? So that's the power of working on an Apple as compared to an Android. But having said that, Android gives you more features. For an Android phone, you've got a lot more features that are OEM based. Like a Samsung gives you, Samsung camera might be the greatest as compared to some other camera, you know? And that's one of the things that happens. So most of you guys might have seen this picture. I wanted to keep it here. This was probably sent out as a joke, saying that, hey, look at how Android has grown and look at what iOS is development is. You know, but I saw it differently. I was like, well, this is great. Why is this great? Because you've got a standard development platform. You've got consistent features all across. And every time you change the processor on this, you don't need to worry. Your screen resolution is the same. Your games are always doing great. I think that's a great thing. I personally think that's a great thing. Whereas when you're developing for Android, you were here, and now you're here. Your screen resolutions are changed, your UI doesn't fit accordingly, the same features that you're expecting to work on one platform don't work on the other one, you know? So basically, Android as a platform for games, I don't think it's like as stable as what Apple provides, which is why Apple games are doing really well as compared to Android.